Hello, my name is Aiden Arabzadeh, and this is the 595 traffic light, my first short ISP. I soldered it on a perma-proto board, and it's encased in a perma-proto board case, which is full size, and it has the name of the project on the side. So when the button's pressed, the traffic lights begin to cycle through their states, and also these LEDs, which represent the cars, turn on according to the traffic light. So as you can see, these 4 LEDs turned on when the light was green, and as it turns to yellow and red, they just flow out of the intersection. And this is a never-ending loop that will go on forever and ever until you press this reset button, which is connected to the SR clear of both of these shift registers. Here are the parts on screen, and now let me explain how this all works. The 595 traffic light consists of 3 inputs: a PB&O, which triggers the circuit, a reset button, and a 1 mega ohm potentiometer. So the start button connects to one input of an OR gate, which connects to the data input of the first 595, and this is the 595 that powers the traffic light LEDs. This top OR gate here is actually made of transistors because I didn't have enough room to put another OR chip onto the full-size perma-proto. The collectors are both connected to power, and the emitters are both connected to ground. So since these are NPN transistors, whenever a high is presented on the base pin of either one, it'll connect it to 2 pins and therefore outputting a high and serving as an OR gate. So when you press the button, a high is outputted on the data pin, and ideally you'll press it for 1 clock cycle. These 595s are both powered by a A-stable 555, and this 1 mega ohm pot can be used to change the frequency. As you can see, this 1 mega ohm pot, which is connected to the A-stable 555, can change the frequency. So if I turn it this way, it goes down, and if I turn it the other way, the outputted square wave of the 555 is much faster. And that'll change the speed of the entire cycle because the output of the A-stable 555 is connected to the SR clock and R clock of both 595s. So let's get back to the circuit. After you press the button, that puts a 1 onto the register. So now it'll just keep on shifting down, and this creates the timing of the traffic light. So here I've OR'd outputs A to D, which are the green light, and outputs E and F and G and H, which are yellow and red respectively. The second 595, which is responsible for the car LEDs, has its data input connected to Q A to B and Q G to H of the first 595. This allows for the car LEDs to shift out high when the green light is on, but when the light changes to yellow and red, they will stop shifting out, and instead it would appear as if the cars are just flowing out of the intersection. To make this a never-ending loop, I connected QG to the output of this OR gate here. Whenever a high is presented on QG, it'll feed into the OR gate and into the data input of the 595, and that will restart the traffic light cycle all over again. Overall, this project was really fun, and in the end, after I debugged all the issues, it felt really satisfying to see it perfectly working, and I'm really happy how the final product turned out. Thank you so much for watching, and I hope you learned something about the shift register traffic light.